Okay, sorry guys, I had a message there real quick. I'm gonna make sure this is up and running here on the YouTubes. Not that anybody really ever watches me anyway, because I'm pretty lame. Mute that. Sorry, I had to send a message there. I apologize, guys. I apologize. Sorry about that. Oh, I see a few handfuls of people. Oh, cool. All right, everybody showed up. Great, great. We're getting more people. Yes, I'm so excited. I am so very excited. I'm so very excited, guys. Really, I am. Yeah, give me 1 second. I will send that link. Let me get that for you. Invite. There's the number. Let me do that. Yep. And I will send this to you. There we go. Copy and paste. Uh-oh. There you go. I think I sent that link to you so you have it. Okay. Awesome. Sorry about that, guys. Oh, great. More people. Yes, yes. More people. More people. This is awesome. This makes me super happy. All right. Excellent, excellent, excellent. Okay, cool, 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 cool. All right. So I'm going to go ahead. I should be spotlighted. Today, ladies and gentlemen, we're going to use your noodle that you have up here to use some noodles to build some pasta towers. Now, this is usually an activity we sometimes do with, usually second, third, fourth graders, but this is a very fun activity that we can do. You can do this all the way up until, you could even do this with high schoolers. Now, what I've put here as your thing to do is 25 pieces of pasta, all right? It can be spaghetti, it could be whatever you want it to be. There's no big deal. If you don't have any pasta, which I was actually looking for like spaghetti noodles or things like that, I actually am out right now, which is strange. Well, actually, no, it's not, because pasta in my house goes real fast. I have a couple minions that decide that they basically eat, sleep, and breathe and live on noodles. They can live on noodles and Parmesan cheese forever. They're just weird. They have no palate. But anyway, so 25 pieces of pasta, 25 mini marshmallows. And yes, you may say, well, what if I have regular sized marshmallows? Use regular sized marshmallows. That's fine. Use what you got. The only problem is when you get to the bigger pieces of things, like the marshmallows, the more weight it's going to add and the more difficulty you're going to have. Really what you want to aim for is you want to aim for like linguine noodles or fettuccine noodles. They're a little bit wider and a little bit flatter, so they'll work pretty good. Some people have like penne or mostaccioli or rigatoni, those bigger tubes. Great. If you have squiggles, have fun with squiggles. There's nothing stopping you from what you have. Just remember, you're going to be down 25 perfectly good marshmallows and pieces of pasta, so you won't be able to eat them, but that's okay. All right. You'll need 1 piece of cardboard, maybe 2 pieces, about 4 inches by 4 inches. Okay. And to think about 4 inches by 4 inches, it's about the size of the palm of your hand. You guys may be a little bit bigger. So if I took this piece of cardboard, it's about the size of the palm of my hand. Again, it doesn't have to be perfect, whatever you've got. Just don't make it too big, okay? Because I don't think your pasta towers are going to end up being very wide. Now, if they do become wide, you got bigger boxes, okay? And then you need some form of weights. What I'll do is I will grab, oh, hey, we got money in there. Sweet. All right, I'll grab my jar of coins. I've got a jar of coins. You can use those. Maybe you have a piggy bank. You can use washers. You could use whatever you've got. Boy, I've got a huge bag of quarters. Sweet. Why do I have a huge bag of? Wow, sweet. I got a bag of quarters in there. Awesome. I can go do laundry or go do a car wash. Sweet. All right. So those are the things that you need. Okay. Maybe you need to use things, a Play-Doh. Maybe you use candy bars. Whatever you've got for weight will work. Whatever you've got for weight will work just fine. All right. So when we use our noodles, we're going to engineer. We're going to engineer a combination. We're going to aim for the tallest and strongest pasta tower that we can get a hold of. Okay. We're hopefully going to aim for both. You may end up building a very short and strong pasta tower. You may end up building a really tall but kind of weak tower. Guys, the sky is the limit with what you want to do. Pasta is not very expensive. You can buy a big bag of spaghetti noodles for like $1 or $2. You could buy a bag of marshmallows for maybe $1 or $2. Really, I'm not asking for a lot. Could you use tape instead of marshmallows? Sure. Could you use toothpicks? Absolutely. Could you use straws? Sure, if you have a bunch of them. There's nothing holding you back. Just have fun with it. So when we talk about this, when we want to go ahead and measure this, we've got some things that are different. We have what's called standard or imperial, or sorry, that's metric, standard or English units, which is inches, feet, you know, things like that. Okay. But in the metric system, which I find to be a lot easier, and in fact, kind of a weird thing, I kind of flip between the two when I'm doing some of my projects. There are some times where millimeters work better, especially for really, 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 really tiny measurements. Okay. But a lot of times inches and feet are easier. Okay. We could go inches and centimeters. They're basically about the same. 1 inch is about 2.5 centimeters, or about the thickness of your thumb, roughly. A yard, a little bit shorter than a meter. A meter is from the floor to the doorknob. So floor to the doorknob is actually a meter. It's about 39.5 inches. A yard is only 36 inches. So a yardstick would end here. Okay. So a yardstick would end right here. Okay. And a meter stick ends right here. All right. This would be a yard. Kind of makes sense. Okay. Pretty easy. We kind of know that. All right. Some other things that we do look at too is we also measure in, you know, miles. We measure in miles. Almost everywhere else in the world measures in kilometers. Okay, so we're one of the weird countries, one of about 3 countries that use the standard English measuring system. Even England, where the ruler came off of, which ruler means the measurement of the actual ruler's foot. That's why it's a ruler. They actually took somebody's foot and measured their foot size, and that became the new foot. But the problem was every time you got a new ruler, you had to change your ruler. So let's say you went from a king who had a really big foot, like a size 14 foot, which could be really big, right? And then let's say that he died and the queen took over. Well, now you shrunk your ruler. Most females' feet are pretty small, down to about 10 inches. So you went from being, you got extra in your foot. So your foot long became not 12 inches, but 14 inches. Okay. And then you switch to a queen who was your new ruler. Well, now your foot long is now only 7 inches. That would stink. You'd be getting less for your money. So this is why they standardize it at 12 inches. It's also kind of why it's a little bit tricky to use, because the standard measurement that we use is based on 4s and 8s and 12s and 16s. Well, actually a lot of 4s, 8s, and 16s. So it's not the prettiest, okay? Because you go to halves, fourths, 8ths, 16ths, 32nds, 64ths, okay? Those are kind of easy to see, but when you get into 64ths, oh boy, it's really tough on measuring, okay? But if you use the metric system, it's all based on the number 10. So you'd have to multiply and divide by 10, or the easiest thing that you get to do is move the decimal either left or right, and that's all you'd have to do. So it would be as simple as something like this, okay? So let's say I had 10, or let's say I had 100 centimeters, okay? Okay, so I have 100 centimeters here, all right? So if I have 100 centimeters and I want to convert it to meters, I know that for every 100 centimeters, it's, you know, 1 meter, okay? So I just take my decimal, which is right here, and I would kind of move it 2 places that way. If I wanted to make it millimeters, I need to multiply it by 10. So I would take my 0, and instead of having to do 100 times 10, I just add another 0. So really the nice thing is making it easier. The other cool thing is, let's say I have 2.5 centimeters. I know this is kind of math. Okay, let's say I have 2.5 centimeters, and I want to know how many millimeters that is. Well, instead of multiplying it, doing this really long thing times 10 and 2 and 5, and move the decimal, That's really frustrating and annoying, okay? All I have to do is take this right here and move it one place over. And then I know that it's 25.4 millimeters. See, that's the nice thing about the metric system. We don't have to work that hard. We just have to measure in bases of 10. So we could, and I know teachers don't want to hear this, we could get rid of most of the fractions. You wouldn't have to see them. It's amazing. You wouldn't have to see that many fractions. You wouldn't have to think about it because fractions, for a lot of people, are kind of a death wish. Well, not really. They're kind of ugly, gross, scary, okay? And if you think that they are, how many of you think fractions are kind of ugly and scary and kind of wild? And yeah, you have a tough time. Guess what? Yeah. Measuring in fractions is tough, okay? Like if you're trying to add 2/3 of a cup plus 3/4 of a cup, you don't get a really nice number, okay? You get a really ugly number. So it's weird because we measure a lot of lengths in like 4ths, 8ths, and 16ths, but we measure our cups of things like if we're baking or cooking in the thirds and halves. It doesn't make much sense. It's kind of weird. And then we get into pints, cups, and quarts, and it's like 2 cups for every pint and 4 quarts in a gallon. It's weird. At least you know in the metric system, everything uses the same prefix, okay? Kilometer, centimeter, millimeter. And you put them in front of all the other ones and you just change your unit. So instead of a liter, you get a milliliter, a really small couple drops, okay? You could get a centiliter, but they don't use that, okay? So it'd be really easy. You get kilograms, milligrams, grams, okay? It's really nice and easy. So just something to think about. We probably won't ever convert to it, but I would be first in line to vote for let's move to metric because it would make everybody's life a whole lot easier, okay? So if we think about it, if I take my little pinky, okay, if you think about it, is it A, I want you to vote in your head, is it A, B, or C? The width of your little finger is about what? 1.5 centimeters, 1.5 meters, or 1.5 kilometers? Pretty easy. It's going to be A, 1.5 centimeters, okay? Thumb, pinky, about 1.5 centimeters. So this is a good 1.5 centimeters, okay? Let's think about this next one, okay? Next one. If I'm going to travel from Nebraska to Texas, am I going to measure it in 800? It's about 821 centimeters. Is it 821 meters? Or is it 821 kilometers? So think about it. Is it centimeters? Centimeters would be only about 8 meters. Meters would be about 821 meters would be 800 meters is like 2 laps around the track. Yeah, you want to measure in kilometers. Big distance, okay? Kilometers, big distance, okay? If I take Kevin Durant here, he's not the average, well, he might be, okay? The average height of an NBA player, is it 2 centimeters, 2 kilometers, or 2 meters? That should be easy. 2 kilometers is 2,000 meters, which is 1.5 miles, or a mile, about 5 laps around the track. No, we're looking at 2 meters. B, pretty simple, okay? If I'm measuring the length of a semi-truck, is it going to be 16 centimeters, 16 meters, or 16 kilometers? 16 kilometers is a long way. I'd pass out if I tried to run that far. It's going to be 16 meters, okay? About 48, 50 feet. That's about right, okay? One last one. The average length of an adult's foot, are we looking at centimeters, meters, or kilometers? 31 centimeters, 31 meters, or 31 kilometers? Yeah, you're looking definitely at A there. Now, if you want to know a little secret, okay, the easiest way to think about to convert it from one to the other, okay, to convert from centimeters to meters, divide it by about 2.5. So that would mean if you divide it by 2, 31 divided by 2 is 15, and then a little bit extra. So probably about 10 to 11 inches, okay? If I want to know how far a kilometer is, I know that there is, try to figure out the easiest way. It's about, I've got to run 5K to run 3. So if you divide it by a little bit over half, so 31 divided by, 31 divided by half is about 15, which would be about right because 10K, 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 6, 12, 18. So it's about half plus a little bit extra. And then if you want to know meters, multiply it by about 3. That'll give you about the right amount of feet. Is that a pretty good little shortcut? Does that help you a little bit? So centimeter to an inch is about 2.5. Going from meters to feet, multiply it by 3 to get feet, and then 31 kilometers, divide it by half because you have more kilometers per mile. Okay. Then the other neat thing is when they talk about kilograms, like if somebody is about 180 kilograms, okay, divide it by 2. So that means they're about 90 to 110 pounds. That gives you a good idea. Okay. Just gives you an idea. All right. So let's talk about what we're going to do. Here is your challenge. Yeah, I'm done. I'm done talking math and numbers. Good. You're going to build the tallest and strongest tower out of pasta pieces and marshmallows. You need to make sure that it can hold your 4x4 piece of cardboard on top, because you're going to put your piece of cardboard on top and then add your weight until your structure finally collapses. Before you can do any measuring, you're going to put your weight on, you're going to put your cardboard on there, let it sit for 15 seconds, and then measure how tall it was. Then start adding weight and then see when it collapses. How much weight did it hold before it collapsed? Okay. If you can do this, if you can take a picture and you can email it to your teacher and they can email it to me, or if you find my email on the ESU5 website, which you can find it, it's my first initial last name at ESU5, you can email it to me. And if there are some people who do this, okay, if you have the tallest and the most weight held, you will become the ESU5 internet winner. But you have to have picture proof, please, not just make up numbers. All right, please, please, please do that. Do you think you guys can handle that for me? Think you guys can handle that? All right, I'm looking to see how well you can do. If you can do great, awesome. If you struggle with this, nobody says stop building it. Can you use the internet for research? Sure. Realize when you start looking at the internet when they do this, the complexity, how hard it's going to be, and what structures they use that work really well gets to be a little complex, and it might take a little bit more patience to build. So you guys understand your challenge. Give me a thumbs up if you kind of understand what we're doing. Give me a thumbs up, kind of know what you're basically trying to do. You don't have to build it right now. Yeah, I see he's going, Basically, you're building it as tall and as strong as you can. Just because you build it super tall doesn't mean that it'll be super strong. And just because you built it super strong doesn't mean that it'll be the tallest. Okay? I don't want to give away the secret because I actually had at Tri-County one of the strongest towers. They used the most unique idea. When we did this with 6th graders, we usually give them a cost. They only get so much money to spend, but you guys don't. Okay, so when we look at how we build our tower, okay, there's going to be a few problems that you're going to run into. I want to show you this tower, and we're going to kind of break it down a little bit. So where's it going to fail? Most of the time, it's going to fail on the sides. It's usually going to fail right here. I can tell you this will maybe fail there, but maybe over here. Because what will happen when you do that, okay, what will happen on the sides every time is when you put the weight over the top, okay, let's say this is your piece of cardboard here. Once you put your weight on top of it, like coins, you put one on one side and then one on the other and here, or if you set it straight, if you have it slightly off-centered, it'll push on the weak points and then it'll cause it to collapse. It will always find the weakest point, and the weakest point is always going to be where your marshmallows grab a hold of your pasta. The pieces won't snap, okay? The spaghetti or whatever will not snap. It's actually much stronger than you think it is. The weakest point is always where you try to glue the marshmallows together, because once you start touching the marshmallows, your oils get on there, it becomes less sticky. The sticky goes on your hand, not on there. So you have to be very careful with how you do that, okay? Does that kind of make sense? All right. The second thing that causes, it's top heavy. So they have these two marshmallows up here. Well, I want the center of gravity. Whoop, make sure you mute yourself there. Okay, I want the center of gravity to be right in the middle, okay? Right here. If I have these if I draw a straight line up here, they're right about the center of gravity, but they're a little bit to the right of it. So if I have a little bit of weight just off to the center, it's going to slowly pull everything this direction. It's going to slowly pull everything this direction. And as it pulls it, it's going to weaken that side. And as it pulls the weight here, this is what's going to kind of fail right in that area. Okay? Right in that area. All right. You're looking at me probably crazy, like this is really complex. This is actually kind of complex once you get going. All right. And then the other problem is trying to solve all of your problems with marshmallows. You can't fix everything with marshmallows. Marshmallows will only go so far because you'll keep touching them. They'll only stay so sticky. They will dry out. You'll try to put a piece of pasta in and then try to remove it. Don't do that. Once you build it with the marshmallow, leave the marshmallow alone. Can you tear the marshmallow apart? Absolutely. Can you break the pieces of pasta to fit? Sure. But when you use too much marshmallow, you actually end up with too much weight. You need to think about the center of gravity. Okay? Remember, I want the center of gravity. Here it is down here, kind of in this base. I want to keep it right in this area, and I want everything to be built around the center. They talk about this in sports all the time. You need a good base. You need a good center of gravity, because if you don't have a good center of gravity, you get knocked over really easy. It's kind of the funny thing. A great way to show this is if you're a female and you push right here, okay, and you can't move side to side, you got to try to stand straight up. If you're a female, because of where your center of gravity is over your hips, okay, you can stand up with your finger on your forehead like this. Now, because I'm a male, I can't do this, okay? No matter how hard I try, I can't push myself up well enough to do this. I can actually hold somebody down and keep them from standing straight up. It's not easy, okay? It's actually really uncomfortable without arching my back, okay? That's kind of cheating and throwing my body. Yeah, if you really want to try it, if you have a brother or sister, if you really want to try it, push their forehead, put a finger on their forehead. You don't have to push very hard, and tell them to stand straight up. Can't move their legs. They got to stand straight up, okay? If you're a girl, you should be able to do it easily because of where your weight is distributed. It's a little bit lower than males, which is great. Okay, if you're a male and you do this, it'll be almost impossible to stand up. Okay, if you don't believe me, try it. Okay, I can even do it to myself. Really, I'm doing it to myself. I can't stand. I can, but it's really, notice I'm having to push my back and I'm pushing myself. But if somebody pushes your head back, even with some pressure, keep them from going over. So those are some things to think about. The sides will always fail. It'll get top heavy and it'll lean one way and you'll try to balance it the other way. That won't work. And just don't use too much there. So here are some ideas, okay? I can tell you this one will be pretty good, but it's gonna have some weak points like right here, all right? This one's gonna be okay right here, but again, it's got some weak points. This one's fine, but it's very pointy, all right? This one's pretty good, but it's kind of disjointed. There's really no place to put a good base. You want a good base, so you kind of need more of a square or some triangles that'll help you. Here's a really good inspiration one for you. This was made out of toothpicks and marshmallows. She built this. Yes, she built this bridge structure. So you could take some of the ideas out of there. In fact, there's a really good thing. Notice what shape are they using a lot of? The really good ones don't use a lot of squares. A lot of them use our friend, the triangle. So to show how to test it here real quick, I built a really simple one real quick, okay? So I built this terrible looking marshmallow thing out of toothpicks. Now, if you look at it, I've got some problems. All right, number one, it's not very square. Number two, it's not very tall. But I did a lot of cross bracing. Now I ran out of toothpicks, so I did some cross bracing here. I did some cross bracing here. Notice I'm using a lot of triangles. Triangles are our friend, okay? This will work. You could just set it on your table, okay? And I would put my base over the top of it. So let's put it here. If you were to look at this base right here, okay, if you're looking at that, where do you think it's going to fail first? If I push on it, where's it going to, oh, I can tell you there's where it's going to fail. Okay, it's going to fail along these parts because there's no X brace there, okay, and it's kind of weak in this corner, these corners. So I'm going to take this, I built it that tall, okay, I'm going to put my weights on here, and so let's see, we'll just put, should we just put the jar on there? Let's just crush it. All right, notice I crushed it. Look at which way it collapsed. It collapsed toward me, okay? So here's where it started, right? Here's where it started. When I put the weight on it, it collapsed this way, okay? So that's where the weak point was, and the weak point, like I told you, was on the side. Whoop, was on the side. So that really is all there is to it. I did it with toothpicks. You guys can do it with pasta. Pasta gives you a little bit more flexibility. It's a little bit cheaper. You don't waste perfectly good toothpicks. And notice this had some major errors. Okay, notice, see, it's really, really weak. Now that I've crushed it once, now it's really, really weak, and I'm gonna have problems. Remember, triangles are your friends. You need to make sure that it holds some weight on the top and do the absolute best that you can. If you make a mistake the first time, try something else. The nice thing that you can do, ladies and gentlemen, if you search pasta and marshmallow towers, there's a few really good websites out there with some really good design ideas. I can tell you a square base is not going to be the best idea. Okay, well, a square base is the best, but squares and X's are not the best idea. Okay, so with that, I'm going to go ahead and stop this screen share. I'm going to go ahead and stop my recording, and I'm going to stop this stream here real quick. Okay, I think I did that up there. That's kind of up in the corner. I should have stopped that. Sorry. Anyway, before we call it a day, ladies and gentlemen, do you have any questions